Hi, we are going to look at a binomial experiment. We're going to do one with the formula and then one with the table, okay? Because sometimes we cannot use the table, and then sometimes the table makes our life a whole lot easier so that we don't have to do the formula multiple times or even just once, and it saves us. Okay, so let's look at first a binomial experiment, and I'm just going to give the variables for you, where n equals 6, p equals 0.17, that's our probability of one success, and r equals 2. It's the number of successes that we want. And so, of course, the binomial is what is the probability of r. So what is the probability that r equals 2? This one we have to use the formula, and the reason why is because of this p of 0.17. We have to, in our table, we have everything rounded to the 0.05. So we have 0.2, okay, and we have 0.15, but we do not have 0.17 on our table. So to get an exact answer here, we would have to use the binomial formula. So let me write the binomial formula. And the probability of r, the first part, is NCR, counting all the different ways that you can select r objects from n. And then we have the probability of a success p raised to the number of successes that we want, which is r. And then we have q raised to the n minus r, which would be the number of failures that want. Q is the probability of a failure. Okay, so this is our formula. We have all of the variables except for q, but we know that q is the probability of a failure. So q is 1 minus p, because p is the probability of a success. And you're going to either succeed or you're going to fail. So they're complements of each other. They cover the sample space. And so we know that q is 1 minus p. They should add to 1. So find that real quick. 1 minus 0.17 is 0.83 for our q. Okay, so let's just plug it into the formula. We'll start with NCR. Our n is 6. Our r is 2. Then we have p with probability of success. We know is 0.17 to the n, which is 6. And then q, 0.83 to the n minus r, 6 minus 2. If you do that in your calculator, calculators can handle this. You can put it all in at once so that you won't have any rounding errors. Okay, so just do your combination. You could probably find your combination, write that down, and then do that times all of this at once. You should get 0.206. So if you wanted to change that to a percentage, probability is 20.6%. Okay. Let's just quickly look at one that we could use the table for. So this is an n of 6, which is on the table, a p of 0.7, so it's rounded to the nearest 0.05, so it is on the table, and then an r of 2. And luckily for the table, we don't even need q, but if we did, it's 0.3, 1 minus p, okay? And then we just simply look it up in the table. You're going to find your block of n equals 6, and then up across the top of the table, you'll find your 0.7, and then find your corresponding r of 2. If you do that, and you should go ahead and do it and check it with me, you should get 0.6. Okay, so there's two binomials. We like it when we can use the table, but of course sometimes we have to use the formula. Great.